13.3 Gas Law Stoichiometry. Gas Law Stoichiometry, our very last chapter of the course. Okay. So, stoichiometry refers to the relation between the number of moles of a reactant and the number of moles of a product in a chemical reaction. So understand that Gay-Lussac's law of combining volumes. When gases react, the volumes of the reactants and the products measured at equal temperatures and pressures are always whole number ratios. So what we're just saying is, even when we're balancing chemical equations of gases, they are still whole numbers, and those whole numbers can be utilized as mole ratios. So, how to solve a gas law stoichiometry problem? Well, as always, all stoichiometry problems write a balanced chemical equation. You need to be able to put together a balanced chemical equation. Okay, be aware of those gases, those double displacement reactions that create further decomposition reactions. You remember those ones that we talked about in what was it, in unit 3? We talked about some of those double displacement reactions that formed gases. So be aware that some of those gases can be produced, and we can utilize the this formula, this ideal gas law, to solve some of those questions. Anyway, so once you've identified your balanced chemical equation, write the given information under the appropriate reactant or product. Put a question mark under the reactant or product for which the information is needed. If you look at my answer keys, I show detail as to exactly, I really try to line up all the information underneath each respective compound. Okay, so notice, there's a reason to where I place things when I'm doing my answer key, because it helps me kind of line up and identify exactly where are these numbers, and what are these numbers from, where are they coming from, what am I referring them to, and whatnot. You're going to be converting anything into moles, so you might use this formula to isolate for N to find the number of moles if you're looking for a gas and comparing the gas with another substance, with another reactant or another product in a stoichiometry problem. Then, next step, you're going to compare the molar amounts using stoichiometry ratios from the balanced equations. What this means is use that table that you'll see me always utilize, right? That moles to coefficient table that you'll see in all my answer keys. Okay, that's what that part means. Understand that we could look at limiting reactants, right? We might have a limiting reactant, question, which case you're able to find the number of moles of both of your reactants, or all three of your reactants. Again, remember, just because we're talking about gas stoichiometry doesn't mean that we can't have limiting reactants, because limiting reactants is part of stoichiometry. And finally, sometimes you might be asked, hey, find the pressure of a gas, find the temperature of a gas, find the volume of a gas. Well, in which case, once you find that N value, right? Using the table, you can throw that into that formula and calculate either pressure, either volume, or lastly, temperature. Okay, and I just included this slide again that you saw in the gas law, in the partial pressure, the Dalton's law of partial pressure equation. But anyhow, let's look at one of the stoichiometry problems here. So, an alchemist liked to use strong sulfuric acids to produce dramatic, dangerous effects. Again, look at that. That's just some, chemistry trivia. Okay, has nothing to do with the question. However, the fact that we're using sulfuric acid, which is one of the, but we refer to it again in the second line anyway. So again, like I said, don't panic when you see questions that are 3 lines or longer, because let's just face it, if you look at it right there right now, we just eliminated one sentence from that question and tried to make that a little bit simpler. Anyhow, so one interesting reaction occurs when sulfuric acid reacts with iron metal to produce a gas and an iron 2 compound. What volume of gas is produced when excess sulfuric acid reacts with 40 grams of iron at 18 degrees Celsius at 100.3 kilopascals? So here, step number 1, write the balanced chemical equation. Step number 2, list the information underneath. Okay, we calculate our moles. Okay, so I'm given the mass of something. I could find the molar mass of it because, hey, let's face it, we know what the formula is, right? And we found the number of moles. So we use the table here. Okay, it's a 1-to-1 ratio, so the volume doesn't change. All right, so I've got my volume. I've been given a temperature, 18 degrees Celsius, which I always convert to Kelvin, 100.3 kilopascals. There is our pressure. So we substitute it into this formula here. Okay, do our multiplication and division finally, and we are left with a volume that is 17.3 liters. So therefore, the volume of hydrogen gas produced is 17.3 liters. Okay, so there you have it. Stoichiometry with the ideal gas law. Again, can't stress the importance of being able to put together your balanced chemical equations. All that we did back in chapter 5, and here we are, chapter 12. Okay, notice how that carries over. Your ability to put together formulas from chapter 4 carries over. When we talked about calculating moles for the mole ratios, right? This is right here and right here. This is all chapter 8, and we introduce this formula here, mass divided by molar mass, back in chapter 6. So notice how this course has been nothing but one big jigsaw puzzle. Okay, that every little piece kind of builds and builds and builds to get to where we are here with this gases unit. I hope you liked this video. If you did, do not be shy to hit that thumbs up button. And while you're clicking the thumbs up, click on that subscribe to stay tuned to my new videos. Thanks for watching.